Hello guys, in this video we'll be going through the differences between parallelism and flatness in GD&T. Many times these two symbols are confused with each other. So we will understand what are exactly the differences between parallelism and flatness when they are applied on the same feature or same surface. So let us take this example of this part over here. So the primary datum feature is the bottom surface, which is datum feature A. And this top surface, as shown, this surface is having the size dimensions as shown 45.6 by 22.7, and the size tolerances are mentioned. And there are two geometric controls applied over here on this surface. One is a form control, which is flatness. So we are saying that this surface in its flatness should be within a tolerance zone of 0.05. And also we are saying that this surface in its parallelism with respect to datum feature A should be within a tolerance zone of 0.1, that is with respect to datum feature A. So two geometric controls are applied. And over here, the form control is a refinement of the orientation control. Always the form control value should be lesser than the orientation control value. So to understand, so the definition of a flatness is basically a geometric tolerance that ensures all points on a surface lie within two parallel planes without any reference to another datum surface feature. So flatness is basically, we are saying that how flat is the surface, but that flatness is not with respect to any other surface or any other datum feature. It is with respect to itself. It basically ensures all points on a surface are basically close to each other, which means that the surface is flat. So the tolerance zone for the flatness will be something like this. So this is a tolerance zone, a rectangular tolerance zone in this view. So basically all of the points on this surface should lie within a tolerance zone of 0.05. That's what it means. We are not locating the tolerance zone with respect to any datum feature. We are not orienting the tolerance zone with respect to any datum feature. It is with respect to itself. So that is the tolerance zone for flatness. In 3D, this is the view. This is exaggerated view. Now, what about parallelism? Parallelism ensures that a surface or axis is equidistant. That is, it is having equal distance across its surface, across the axis, with respect to a datum surface feature. So tolerance zone for parallelism, you can see the shape is the same as compared to flatness, but this tolerance zone is being located from the datum feature A at a basic dimension of 35. So the center plane of this tolerance zone is being located at 35 basic, and then we find out the points on the surface, whether the points on the surface are lying within this tolerance zone or not. So here this tolerance zone is not located with respect to any datum feature, whereas this tolerance zone is being located with respect to a datum feature. That's the major difference in terms of tolerance zone definition. To understand better, let us go through one of the inspection processes of inspecting flatness and parallelism. One way of doing it is using coordinate measuring machines. Now, coordinate measuring machines are a very common way of inspecting parts, especially in high volume productions. It is costly way of inspection, but it is more accurate as compared to other inspection processes. So what exactly is a coordinate measuring machine? Basically, a coordinate measuring machine has a probe as shown, and this probe moves around in a 3D space. So there is a 3D space which is constructed, which is basically the physical 3D space is converted into a digital 3D space, which is shown over here in this display. And this probe is used to plot points in the 3D space. And those points, and based on those points, we know whether a surface, a feature is within spec or not. So basically we are creating a digital twin of the part in the system and finding out whether the part is as per the specification or not. That is the CMM measuring method, which is very commonly used in high volume production for high stakes parts. It's very reliable and very accurate way of measuring parts. So in flatness, how is it inspected? First of all, the part is set up in the coordinate system of the machine. So each machine will have a coordinate system as shown. So there will be an origin for the coordinate system, and then the probe, which is this probe, is brought into contact with the surface, which is this surface. And as the probe keeps touching onto the surface, there are various points which are collected as shown. 1, 2, 3, 4. Various points are created, and these points create a point cloud in 3D workspace. And then there are two planes which are created, best fit planes, depending on the points which have been probed. These two best fit planes, which are created as parallel planes, they enclose all of the points which have been collected. And then the distance is measured in the 3D workspace between these two planes. And if the distance measured between these two planes, these two parallel planes of the surface, if it exceeds the value which has been mentioned in the feature control frame, it means that the part does not pass in terms of its flatness. So the deviation of the flatness is measured by measuring the distance between these two planes, which are created by a point cloud, which is probed using the probe on the CMM, basically probing the surface which has to be measured. So this is flatness. We get a point cloud and we basically check the point cloud whether the extreme variation between the highest point and the lowest point is within the specification as per the flatness or not. Now if we are using the same coordinate measuring machine to inspect parallelism, the procedure is that the part is first set up in the coordinate system of the machine. So you have a coordinate system, you set up the part in the coordinate system of the machine and probe the datum feature surface. So first the datum feature surface is probed. That is this surface, the bottom surface, which is the datum feature. This surface is first touched with the probe and we get all the points, and then a best fit plane is created, which is the datum plane A, that is constructed, and this is the reference plane. So the probe is contacted at the bottom surface of the part, which is the datum feature A. A plane is created, a best fit plane is created, which is the reference plane. And from that reference plane, two planes or tolerance zone is created, with the center of that tolerance zone being at a basic 35. So in the 3D workspace or in the workspace in the CMM, a tolerance zone is created at 35 mm distance from the reference plane. And this tolerance zone, the width of this tolerance zone is nothing but the value which is mentioned in the feature control frame. So creating a tolerance zone or two planes spaced apart by value mentioned in the feature control frame at a location of 35. So we are creating this in the 3D workspace in the CMM. And then in the same setup, as the part has been set up in the coordinate measuring machine, in the same setup, then we bring the probe to the surface which has to be probed, and then we collect the points. So it is probed, the probe is touched at various points on the surface, we get the points, and then we find out whether these points are lying within the tolerance zone or not. If these points are lying, all of the points are lying within the tolerance zone, then the part is acceptable as per the parallelism control. So this is how it is inspected using the CMM machine. Of course, there are other multiple ways of inspecting parallelism and flatness, which are using surface plates, using dial gauges. But CMM machines are the most accurate and are very commonly used for high volume production parts, especially in automotive industries for critical components. So this is the difference in inspection process between flatness and parallelism. Now just to get an intuitive understanding of flatness and parallelism, here is an example of a part which is having a surface which is not parallel but is visibly flat. So you can see that this surface is not parallel with respect to this surface, but it is having high degree of flatness because this line is straight. If it was wavy, it is not flat. Whereas over here, the surface is not parallel and also it is not flat. It is wavy and it is not parallel with respect to this datum feature A. So you can see the difference. Here the surface is not parallel but visibly flat, but here the surface is not parallel and also not flat. So that is the difference between parallelism and flatness.